Hello everyone, today we are going to learn about the subtraction of two 8-bit numbers. Now one thing we should remember about subtraction, that subtraction always takes place from the larger number and the smaller number. The larger number should be entered first and then our smaller number. So let's check out the program. The first instruction LXI hex 2501 hex will input our first number which should be greater than the other number, and then move A, M will transfer the content of the memory location to the accumulator. Now INX hex will increment our next location, that is 2502 hex, where we will input our smaller number. Now the sub instruction will subtract the smaller number from the greater number and store the result in the accumulator. The INX hex will increment the next location where we will see our result. Move M, A will transfer that result from the accumulator to a desired memory location, and then we will terminate our program with the help of the HLT or halt instruction. Now how will we write our program? Let's check out. We have used three columns: starting address, mnemonics and opcode. It is almost similar like the addition program, but some points are different. As LXI hex 2501 hex is a 3 byte instruction, so we have 3 memory location for it, and the others are 1 byte instruction, so only 1 memory location are required for the rest of the instruction. Now the list of opcodes that is visible in the right hand side column is obtained from any standard book, or can also be obtained from the 8085 simulator app. 21 is the opcode of LXI hex. The 2501 hex 16-bit address can be broken into two parts. First 8-bit is 01 and then the 25. Move A, M is 1 byte instruction, so we have used only 1 memory location. The corresponding opcode for it is 7E. INS hex is also 1 byte instruction, so 1 memory location is required. The opcode for it is 23. Sub M is also an 1 byte instruction and the opcode for it is 96. Again INS hex and then move M, A, it is 77 and then halt. Now we can see that the move A, M and move M, A are somewhat similar but little bit different. In move A, M we have to transfer the content of memory location to the accumulator, and in move M, A we will transfer the content of the accumulator to the memory location. So we can see the opcode are different. The first digit, that is the MSB, is same, but the LSB of both the opcodes are different. For move A, M we have 7E, and for move M, A we have 77. Now let's check out the result part. Here is the result. We will write the result in like this order. We have taken 08 and 03 as a two 8-bit number, and the result is 05, which we will see in 2503 hex memory location. Now let's do our program in the 8085 simulator. This is the 8085 simulator. We will click and this page will be open. Then we will do our program. One thing I should tell you, that the list of opcodes can also be obtained from this section. Now if we know any instruction and we don't know its opcode, we can press that instruction over here and obtain the opcode from this list. For example, we do not know the opcode of STA, we can write it over here and then we will get the opcode of STA as 32. And if we know the mnemonics and don't know the opcode or anything else, we can press this arrow. We will get the list of instructions in alphabetical order. Now this is the opcode to mnemonics, that is from opcode to mnemonics, and the reverse can also be obtained. If we know any opcode, we can get the instruction. Suppose we know 21, so as we have pressed 21, we can get that the 21 is the opcode for LXI hex. Now let's come to the program part. So we will follow the steps to write the program. That is, first we will reset, then press the subset mem button, and then we will input our starting address. We have taken 2000 as our starting address, so 2000, then we will press next and we will enter our opcode serially. So for the first opcode is 21 for LXI hex, and then the 16-bit address is broken, and then we will input our next opcode 7E, then 23, then 96, then again 23, then again 77, and the last is 76, which is our halt opcode. So after writing the next instruction and next opcode, we will get 76, and after this we will press the next button and then reset and then go, then starting address and then execute. This E means we have successfully written our program. Now we will give the numbers to the simulator. So reset subset mem 2501 hex. We have taken 08 as the first number, so we will put 08, and 2502 hex we will put 03. So we should always remember that as it is acting as a memory chip, so something or some opcode is always written over here in the memory location, so we have to overwrite over it. Now we will again follow the same step to execute, that is press next, then reset, then go, then starting address and then execute. The second appearance of E means we have successfully input our numbers. Now we will show our result, that is to reset subset mem, our output address is 2503 hex 05. 08 minus 03 is 05, and here is our result. I hope students have understood how to write simple programs in the simulator and run them. The only thing they should know how to use the instruction and when to use what instructions, and that's it. So looking forward to our next video. Thank you everyone.